February 14, 1945. Oberkommando West Headquarters, Bad Neuenahr, Germany. SS-Oberführer Heinrich Brandt lifted the intelligence report from his desk, his lip curling as he read. A career officer with 17 years in the Wehrmacht before transferring to the Waffen-SS, Brandt had seen the Reich's fortifications hold against every Allied assault from Normandy to the Rhine. "Look at this," Brandt said, tossing the document across the mahogany table. "The Americans think they can bridge the Rhine with their toy pontoons and Negro labor battalions." Major Wilhelm Kessler, his chief of staff, nodded from his position near the strategic map. "Their engineering corps is a joke, Herr Oberführer. At Remagen, we destroyed their bridgehead in 48 hours. Hauptmann Otto Fischer, intelligence officer for Army Group B, leaned forward with careful precision. "The production reports from the Ruhr suggest they are manufacturing explosives and bridging equipment at unprecedented rates, Herr Oberführer." "Perhaps we should," but Brandt waved him off with an impatient gesture. "Fischer, we have demolished 127 bridges across the Reich. Our demolition teams have destroyed every crossing the Americans attempted. At the Ruhr, 12 of their engineer battalions failed. At the Saar, their bridging operations lasted 6 hours before we obliterated them. At Trier, we killed 340 American engineers in 3 days." The mathematics were undeniable. German defensive engineering had a 97% success rate against American river crossing attempts. What Brandt didn't know, what none of them could have known as they studied maps in that comfortable headquarters, was that American combat engineers would cross the Rhine in 17 locations within 14 days. The numbers would become catastrophic. 247 German defensive positions destroyed in 96 hours. 4,200 tons of American explosives expended in the first week. 892 German bunkers demolished. The confidence in that headquarters would become history's most expensive miscalculation, measured in 34,000 German casualties at the river crossings alone. Witness the mocker Brandt. At Arnhem, German forces had destroyed the bridge and trapped the British 1st Airborne Division. Casualty ratio, 8,947 Allied casualties to 1,485 German. At the Ruhr River dams, Wehrmacht engineers had flooded the valley for 2 weeks, delaying 9th Army's advance. American losses, 894 engineers drowned or killed. German losses, 47. At the Ludendorff Bridge approach, German artillery had killed 623 American engineers in the first crossing attempt. The pattern held across every river. German defensive demolitions exceeded American offensive engineering capabilities. Brandt had personally overseen the destruction of 14 bridges across the Rhineland. His teams had placed 67 tons of explosives in prepared positions along a 140-kilometer front. Every bridge, every ferry point, every ford had demolition charges wired and ready. The equipment specifications told the story. German engineers employed 88 anti-tank guns with 2,800-meter effective range, positioned to destroy bridging equipment. Nebelwerfer rocket batteries provided area saturation with 158-kilogram high-explosive warheads. Concrete bunkers with 2.5-meter walls housed MG-42 machine guns, firing 1,200 rounds per minute. The 116th Panzer Division held reserve positions within 45 minutes of every crossing point. Brandt's own SS Division maintained 3 engineer battalions trained specifically in bridge demolition and defensive mining. They had laid 14,700 Teller mines and 8,900 S-mines across approach routes. Recent American failures confirmed German superiority. At Düren, the 291st Engineer Combat Battalion lost 127 men and all equipment in 4 hours. At Jülich, the 51st Engineer Combat Battalion's Bailey Bridge collapsed under artillery fire after 23 minutes. At Linnich, the 1,104th Engineer Combat Group lost 6 complete bridge sections and 89 vehicles to German demolitions. The 237th Engineer Combat Battalion abandoned bridging operations after losing 40% strength. The 254th Engineer Combat Battalion's pontoon bridge sank after German frogmen attached explosives, killing 67 engineers. Brandt's combat record spoke volumes. He had commanded the demolition of the bridge at Nijmegen, killing 234 American engineers. His teams destroyed the Cologne-Deutz bridge 3 minutes before American forces arrived. At Koblenz, his engineers demolished 4 bridges in 1 morning, trapping 2,400 American troops on the wrong side of the Rhine. He had received the Knight's Cross with oak leaves for defensive engineering operations. His unit had a 100% success rate. Every bridge designated for demolition had been destroyed before enemy capture. Witness the Warner Fischer. Fischer's concerns centered on documented American industrial capacity. American factories were producing 47,000 tons of TNT monthly. American steel mills fabricated 12,400 tons of Bailey Bridge components weekly. American shipyards launched 340 landing craft suitable for river crossing operations in January alone. He had compiled reports showing that Bethlehem Steel's single facility in Pennsylvania produced more structural steel monthly than the entire remaining German steel industry. The Monsanto facility in Texas manufactured more explosives in 1 week than all German chemical plants combined produced in a month. But Brandt dismissed the data. Production means nothing without training and will, Fischer. They have factories. We have soldiers. Witness Lieutenant Hans Müller. Lieutenant Hans Müller, a combat engineer with the 47th Engineer Battalion, had seen American bridging attempts fail repeatedly. At Monschau, he had watched German artillery destroy 3 American pontoon bridges in succession. The Americans kept trying. The Germans kept demolishing. Müller had personally detonated charges that dropped the Euskirchen Railway Bridge onto an American engineer company, killing 41 men instantly. He had mined approaches so effectively that 2 American bulldozers hit Teller mines before reaching the river. The German defensive system worked. The mathematics seemed irrefutable. Detroit, Michigan, November 1944. John Morrison walked the production floor of the River Rouge Ford facility, watching as another 40-ton M2 treadway bridge rolled off the assembly line. This single facility produced 340 bridge sections daily. Every 4.2 minutes, another section completed final assembly. Every 17 minutes, a complete 60-foot span was ready for shipment. Every hour, enough bridging equipment to cross a 200-foot river gap left the factory. In September 1943, America produced just 1,240 feet of tactical bridging monthly. By March 1944, production reached 18,700 feet monthly. By October 1944, Ford's River Rouge facility was producing 102,000 feet of tactical bridging daily. This single facility was producing more bridging equipment than Germany, Italy, and Japan combined produced in all of 1944. Witness, the Warner Fischer receives reports. Margaret Kowalski, previously a seamstress at a Detroit clothing manufacturer, now operated the pneumatic riveting equipment that attached steel deck plates to bridge stringers. She produced 840 completed connections every 8-hour shift. Each rivet had to withstand 12,000 pounds of shear stress. Each connection underwent acoustic testing. Her single riveting station's daily output exceeded the entire monthly production of the Krupp works at Essen. She worked alongside 740 other women on the bridging assembly line. Together, they produced enough bridge sections in 1 week to span the Rhine 17 times. Margaret earned $1.87 per hour, time and a half for overtime, with a $50 monthly war bond purchased automatically from her paycheck. She ate lunch in a cafeteria that served 8,400 meals daily, with choices including roast beef, fried chicken, or baked ham. The cafeteria discarded 340 pounds of food daily as waste. The entire German 15th Army received 280 pounds of meat weekly for 65,000 soldiers. James Washington from Birmingham, Alabama, operated the hydraulic press that formed the curved approach ramps for Bailey Bridge sections. His press exerted 2,400 tons of pressure, bending half-inch steel plate into precise 12-degree curves. He produced 96 completed ramps per shift. His single station's daily output exceeded the total production of the Skoda works in Czechoslovakia, which produced 71 bridge ramps monthly for the entire Wehrmacht. James worked the night shift, 10 p.m. to 6 a.m., earning $2.14 per hour plus a 15% night differential. The press consumed 340 kilowatts of electricity per hour. The single press's monthly electrical consumption exceeded the total power allocation for all German bridge fabrication facilities combined. Robert Patterson, $1-a-year man from U.S. Steel, managed the quality control operations that tested every bridge component before shipment. His department tested 4,200 welds daily using X-ray equipment. They proof-loaded 840 bridge sections weekly to 150% of design capacity. They rejected 3.7% of production as failing specifications. The rejected components were melted down and recast. The tonnage of rejected bridging steel in 1 month exceeded the total steel allocated to German bridge production for an entire year. Patterson had left a $150,000 annual salary to work for $1 symbolic pay, managing a quality control staff of 670 inspectors. Americans discarded 2,400 pounds of welding rod daily as too short for efficient use. Germany allocated 140 pounds of welding rod monthly to each engineer battalion. The waste from a single day's bridging production at River Rouge exceeded the entire monthly allocation for all German engineer units on the Western Front. Workers threw away steel offcuts totaling 18 tons daily. German engineer depots issued 11 tons of structural steel monthly to all units in Army Group B. Americans used Bailey bridge pins once, then discarded them even though they remained serviceable. Germans reused bridge pins until they fractured, which caused the collapse of the bridge at Remagen when American engineers captured it. The cafeteria discarded more coffee daily than the entire 15th Army received monthly. The facility's scrap aluminum from 1 week could have built 140 Messerschmitt fighters. The discarded brass fittings from rejected bridge components exceeded Germany's total monthly brass production. Fischer received production intelligence in January 1945. A single American factory produced more in 1 month than Germany's entire bridging capacity. He briefed Brandt, "The Americans are producing tactical bridges at a rate that exceeds our demolition capacity. We cannot destroy them faster than they can build them." Brandt read the report and dismissed it. "Let them build bridges. We will blow them up. That is what engineers do." The Pantex Ordnance Plant in Amarillo, Texas, produced 1.4 million pounds of TNT weekly. Every 3.7 minutes, another 55-gallon drum of high explosive completed processing. Every hour, 890 pounds of military-grade explosives left the facility. The plant employed 4,200 workers across 3 shifts. It consumed 14,000 tons of toluene monthly, imported from Texas oil refineries that produced more toluene as a waste byproduct than Germany's entire chemical industry, synthesized deliberately. This single facility produced more military explosives than Germany, Italy, and Japan combined. Mary Chen, from San Francisco, operated the nitration tanks that converted toluene to trinitrotoluene. She monitored temperature controls that maintained the reaction at precisely 83 degrees Celsius. Each batch produced 2,400 pounds of TNT crystals. She processed 4 batches per shift. Her single workstation's weekly output exceeded the total monthly production of the IG Farben facility at Ludwigshafen, Germany's largest remaining explosives plant. Mary had a bachelor's degree in chemistry from Berkeley. She earned $2.34 per hour managing a process that required monitoring 17 gauges, adjusting 4 valve controls, and maintaining detailed production logs. The facility paid for her to pursue a master's degree through night classes. Americans discarded TNT that failed crystallization purity tests at 99.2% instead of 99.5%. The discarded explosive from quality control testing exceeded the total monthly explosive allocation for German combat engineer units. Workers threw away containers that had held explosives even though they retained residual TNT. German engineers scraped these containers and recovered every gram. The waste from single days' explosive production exceeded Germany's monthly allocation to the entire Western Front. The cafeteria threw away more sugar daily than German engineers received for explosive synthesis monthly. Testing ammunition expended 340,000 pounds of explosives monthly to verify quality. This exceeded the total combat allocation for all German engineer demolition operations on both Eastern and Western fronts combined. Witness, the Warner Fischer compiles data. Fischer watched the production statistics accumulate. American industrial capacity was not just greater than German capacity. It was greater by orders of magnitude. A single American facility exceeded entire German industrial sectors. He prepared another briefing for Brandt showing that American combat engineers would have unlimited supplies of explosives, unlimited bridging equipment, and unlimited replacement capacity. Brandt scheduled the briefing, then canceled it to attend a ceremony honoring SS veterans. March 7, 1945. Ludendorff Bridge, Remagen, Germany, 1547. Lieutenant Müller was inspecting demolition charges on the bridge's southern tower when he saw American armored vehicles approaching from the west. Shermans from the 9th Armored Division. At 15:47, the first tank crossed the railway embankment 800 meters from the bridge. At 15:49, German defenders detonated preliminary charges that failed to drop the span. At 15:52, Müller triggered the main demolition charges. Elapsed time from engagement to attempted demolition, 5 minutes. The bridge shuddered but remained standing. American engineers had cut the wires to 3 of 4 main charges during their approach. At 15:54, American infantry began crossing the intact bridge. At 15:58, the first Sherman tank reached the eastern bank. Kill time for the bridge demolition failed. Total German defensive preparation, 4 months of mining and charge placement. Total American neutralization time, 11 minutes. The 9th Armored's approach had been covered by the 47th Infantry Regiment. Combat engineers from the 291st Engineer Combat Battalion accompanied the assault. Sergeant John Grimball cut demolition wires as small arms fire hit the steel around him. Corporal Alex Drabick became the first American soldier across, reaching the eastern tower at 16:01. Engineers following immediately behind began cutting additional wires and throwing German demolition charges into the Rhine. At 16:07, German artillery began targeting the bridge. At 16:12, the first 88 rounds hit the western approach. At 16:18, American engineers had cut all remaining demolition circuits. At 16:23, the 276th Engineer Combat Battalion began crossing with additional equipment. At 16:34, American engineers started constructing a parallel pontoon bridge 400 meters south. Total engagement duration, 47 minutes. German defensive position destroyed. American losses, 9 killed, 27 wounded. German losses, bridge intact in enemy hands, 126 prisoners, 41 killed. Kill ratio, American victory without losing the objective. The ammunition expended in this 47-minute engagement exceeded Germany's monthly allocation for engineer demolition operations across the entire Western Front. American engineers used 840 pounds of C2 plastic explosive to clear German mines on the eastern approach. German engineers allocated 90 pounds monthly per battalion. American engineers threw German Teller mines into the river rather than defusing them. 67 mines disposed of this way. German engineers received 12 mines monthly for all defensive operations. Witness, the mocker Brandt receives reports. Brandt read the Remagen reports in disbelief. Müller's after-action report described systematic American neutralization of prepared demolitions. The Americans had engineers specifically trained in demolition disarmament. They moved with the assault infantry. They carried equipment for cutting circuits under fire. "This is an aberration," Brandt told his staff. "One bridge, we will destroy the next 50 they attempt." Intelligence dismissed the reports as the confusion of a failed mission. Müller had obviously not placed charges correctly. The American success was luck, not skill. German engineers had demolished 127 bridges successfully. One failure meant nothing in the pattern. Brandt ordered increased vigilance at remaining crossing points, but changed nothing in defensive doctrine. Witness, the Warner Fischer's warning. Fischer reported to headquarters with updated intelligence. The Americans have trained 47 engineer combat battalions specifically for river crossing operations. They have stockpiled bridging equipment at forward depots. Production reports indicate they can sustain simultaneous crossing operations at multiple points. We should expect coordinated assaults with overwhelming material superiority. He presented data. American production exceeded 47,000 tons of explosives monthly. German production had fallen to 2,800 tons monthly. A single American facility exceeded total German output. American steel production for bridging equipment was 340 times German capacity. Fischer recommended concentrated defense at probable crossing points and immediate demolition of all remaining bridges. His report was filed and not acted upon. American engineers deployed 3 types of tactical bridges. M2 treadway bridges capable of supporting 40-ton vehicles across 200-foot gaps. Bailey bridges assembled from prefabricated panels that could span 400 feet. And pontoon bridges built from floating sections supporting wooden decking. American production produced 47 complete Bailey bridges monthly. Germany's entire remaining bridge production managed 4 traditional bridges monthly using conventional construction. American engineers could assemble a Bailey bridge in 17 hours with a single combat battalion. German engineers required 4 days with 2 battalions to construct an equivalent span using traditional methods. They tried concentrating anti-tank guns at likely crossing points. The Americans suppressed them with artillery fire that expended more ammunition in preparatory barrages than German artillery allocated monthly. They attempted demolishing approach roads. American bulldozers graded new roads in hours. They positioned Nebelwerfer batteries to saturate crossing areas. American counter-battery radar located and destroyed German artillery within minutes of the first rounds being fired. They deployed frogmen to attach explosives to pontoon bridges. American security patrols with automatic weapons killed the frogmen before they reached the bridges. March 22, 1945, Nierstein, Rhine River, 2200. The 5th Infantry Division's 10th Infantry Regiment began crossing the Rhine in assault boats from the 150th Engineer Combat Battalion. At 2200, the first wave of 12 boats entered the water. At 2214, all 12 boats reached the eastern shore. At 2218, German defensive fire began. At 2231, 47 additional boats had crossed carrying 850 infantry. At 2247, engineers began assembling a pontoon bridge. At 2315, the first vehicles crossed the completed bridge. Elapsed time from first boat to operational bridge, 75 minutes. Kill time per defensive position, 317 minutes each. German defensive positions destroyed, 17 bunkers, 4 machine gun nests, 2 anti-tank gun positions. American losses, 11 killed, 34 wounded. German losses, 340 prisoners, 89 killed. Kill ratio, 14:1 favoring Americans. The ammunition expended in this 75-minute engagement exceeded the monthly ammunition allocation for the entire German 7th Army. The witness Müller observes. Müller watched from a defensive position 400 meters from the Nierstein crossing. American engineers worked with mechanical efficiency. They assembled pontoon sections while under fire. Artillery support suppressed any German position that fired. Infantry secured the eastern bank in minutes. The bridging operation never stopped. Germans fired. Americans advanced. More engineers appeared. More equipment arrived. The crossing succeeded through overwhelming material rather than tactical brilliance. Müller's position received orders to hold. They held for 34 minutes. American artillery destroyed the position. Müller and 6 survivors retreated. His unit lost 37 men. The Americans continued crossing. Fischer presented final intelligence to Army Group B headquarters. American engineers have demonstrated crossing capability that exceeds our defensive capacity. At Remagen, they neutralized 4 months of preparation in 11 minutes. At Nierstein, they completed an opposed crossing in 75 minutes. They have the equipment and training to cross simultaneously at any point along the Rhine. He showed production figures. American bridging production exceeded German demolition capacity by 17:1. American explosive production exceeded German production by 28:1. They can build bridges faster than we can destroy them. They can sustain losses we cannot replace. A single American engineer battalion has more equipment than our entire Army group. Production statistics confirmed Fischer's analysis. American production of Bailey bridge components, 12,400 tons monthly. German production of equivalent bridging, 180 tons monthly. A single American factory exceeded Germany's entire output by 69 times. American production of pontoon bridge sections, 840 complete bridges monthly. German production, 12 bridges monthly. American production of TNT, 47,000 tons monthly. German production, 2,800 tons monthly. This single American explosive plant produced more than all German chemical facilities combined. Brandt reviewed the data and dismissed it. Production statistics do not win wars. Soldiers win wars. Our defensive engineering has held against every Allied assault for 5 years. The Rhine will not fall because Americans have more factories. He ordered continued preparation of demolition charges at all remaining bridges. He concentrated engineer battalions at probable crossing points. He positioned demolition teams with authority to blow bridges on their own initiative. The defensive plan remained unchanged. The 6th Armored Division attempted crossing at Oppenheim. German defenses destroyed the first 2 pontoon sections. American engineers launched replacement sections within 8 minutes. German demolitions destroyed an approach ramp. American engineers had a replacement ramp in position within 12 minutes. Germans concentrated artillery on the crossing point. American counter-battery fire destroyed 4 German artillery positions within 7 minutes. The crossing continued. At Worms, the 7th Army's crossing faced similar German resistance. Every destroyed section was replaced. Every demolished position was bypassed. Every German defensive success was overwhelmed by American material superiority. March 24, 1945. Wesel, Rhine River, 0200. The British 6th Airborne Division and U.S. 17th Airborne Division executed Operation Varsity, the largest single-day airborne operation of the war. At 0200, preliminary artillery bombardment began. At 10:00, 1,696 aircraft dropped 16,870 paratroopers east of the Rhine. At 10:47, 1,348 gliders landed 614 vehicles and equipment. By 14:00, Allied forces controlled all objectives. German defensive positions were systematically destroyed by overwhelming firepower and simultaneous assault. American engineers from the 291st Engineer Combat Battalion, the same unit that had captured Remagen Bridge, began bridge construction at 11:00. At 14:30, the first Bailey Bridge section was in place. At 21:00, the bridge was operational. Elapsed time, 10 hours. German attempts to destroy the bridge included artillery fire from positions 8 kilometers distant, airstrikes by 4 remaining Luftwaffe aircraft, and a frogman team. American fighter cover destroyed the aircraft within 4 minutes of their appearance. Elapsed time from sighting to destruction, 4 minutes per aircraft. American security killed the frogman team. German artillery fire hit the bridge approach twice. American engineers repaired damage within 17 minutes each time. The bridge remained operational. The fuel consumed in this single day's air operation exceeded German monthly fuel allocation for all air and ground operations on the Western Front. The ammunition expended exceeded German monthly production across all calibers. American engineers used explosives to clear obstacles that exceeded German combat allocation for an entire month. They discarded damaged bridging sections that could have been repaired. The waste from this single operation exceeded German capacity to produce equivalent equipment. Witness, the Warner Fischer compiles losses. Fischer tracked the crossings, Remagen on March 7, Nierstein on March 22, Oppenheim on March 22, Boppard on March 24, Worms on March 26, Mainz on March 28. 15 successful American crossings in 21 days. Every prepared German demolition failed or was overcome. German defensive engineering had a 100% failure rate once Americans brought systematic engineering capacity to the assault. Fischer documented that German engineers destroyed more bridges before American contact than during American assault. At Cologne, Germans demolished their own bridge. At Koblenz, Germans demolished their own bridges. At Mannheim, Germans demolished their own bridges. American engineers crossed using temporary bridges at every location within 48 hours. At Dülmen, American armor production facilities produced replacement vehicles faster than German anti-tank guns could destroy them. The 3rd Armored Division lost 47 tanks to German fire in 1 week. American factories replaced 47 tanks in 31 hours. At Paderborn, ammunition expenditure exceeded monthly allocations. American factories produced replacement ammunition faster than combat units could expend it. American logistics transported supplies to the front faster than German logistics could retreat with remaining equipment. Americans discarded damaged equipment rather than repairing it. At Remagen, American engineers abandoned a damaged bulldozer. German engineers would have spent 2 weeks recovering and repairing it. Americans requested a replacement, which arrived the next day. At Oppenheim, American engineers discarded 40 feet of damaged Bailey Bridge decking. The steel in that discarded section exceeded the monthly steel allocation for German engineer operations. American engineers threw away pneumatic tools that malfunctioned. Germans repaired tools until they could not be repaired, then fabricated replacement parts by hand. The cafeteria at forward engineer bases served hot meals 3 times daily. Soldiers ate roast beef, turkey, ham, fresh vegetables, fresh bread, butter, and dessert. The 291st Engineer Combat Battalion's mess hall discarded 180 pounds of food daily after meals. The German 352nd Infantry Division, defending the Rhine, received 240 pounds of food daily to feed 8,400 soldiers. American engineers in one battalion ate better than an entire German division. The waste from American engineer operations exceeded German combat rations. Aluminum scrap from discarded equipment containers exceeded German monthly aluminum allocation. The 1,104th Engineer Combat Group discarded 2,400 pounds of aluminum from damaged equipment in 1 week. German engineers received 890 pounds of aluminum monthly for all operations. American discarded packaging materials, wooden crates, steel banding, cardboard boxes, exceeded materials available to German engineers for construction. The waste from American logistics exceeded German logistics capacity. Discarded ammunition from training exceeded German combat allocation. American engineers trained with live explosives. They learned demolition techniques by actually demolishing structures. They practiced bridge building with actual bridge sections. Training consumption exceeded German combat usage. The 51st Engineer Combat Battalion used 4,700 pounds of TNT in training exercises in February 1945. German engineer battalions received 320 pounds of TNT monthly for combat operations. This single aspect of American training exceeded entire German combat capacity. Witness the Mocker-Brandt's final battle. April 1, 1945, Ruhr Pocket. The trapped remnants of Army Group B attempted breakout. Brandt commanded rearguard demolition operations. His engineers prepared bridges for demolition as American forces advanced. At Hagen, they demolished a railway bridge. American engineers had a replacement tactical bridge operational within 9 hours. At Wuppertal, they demolished a highway bridge. American engineers bypassed it with a pontoon bridge within 4 hours. At Solingen, they demolished 3 bridges in succession. American engineers crossed using assault boats and constructed a Bailey Bridge within 14 hours. At 1423, April 14, 1945, SS-Oberführer Heinrich Brandt was directing demolition of a bridge near Dusseldorf when American artillery fire targeted his position. At 14:23:47, the first round landed 23 meters from his position. At 14:24:09, the second round landed 8 meters away. At 14:24:31, the third round scored a direct hit on the bunker where Brandt had taken cover. Elapsed time from first round to kill, 44 seconds. Kill time, 44 seconds. The American artillery battery was from the 991st Field Artillery Battalion, firing 155 howitzers. They had located Brandt's position using radio direction finding equipment and forward observer reports. They fired 6 rounds for effect. 3 hit the target. Ammunition expended, approximately 840 pounds of high explosive. This exceeded the monthly allocation for the entire German artillery regiment supporting that sector. April 18, 1945. German engineers defending the Ruhr attempted coordinated demolition of all remaining bridges. They had explosives, they had trained personnel, they had prepared positions. American engineers crossed at 17 locations simultaneously. Every bridge demolition succeeded. Every crossing succeeded anyway. American engineers used assault boats, pontoon bridges, and Bailey bridges to cross within hours of German demolition. The defensive strategy of bridge demolition failed not because Germans executed poorly, but because Americans had unlimited capacity to bypass demolished bridges. The 291st Engineer Combat Battalion alone constructed 7 tactical bridges across the Ruhr in 5 days. Each bridge supported 40-ton vehicles. Each bridge was constructed while under fire. Each bridge became operational faster than German engineers could organize demolition of the next target. This wasn't combat. This was systematic demonstration of industrial capacity translated into tactical superiority. German engineers fought with courage and skill. American engineers won with unlimited equipment and trained manpower. May 1945, Interrogation Center, Wiesbaden, Germany. Hauptmann Otto Fischer, the intelligence officer who had warned repeatedly about American production capacity, provided testimony. We were not defeated by better soldiers, but by better factories. American production of bridging equipment exceeded our entire national output by factors we could not calculate because the numbers seemed impossible. A single American facility produced more than our entire industrial base. They achieved in hours what required us days. They discarded in waste what we carefully rationed. The mathematics were brutal. One American engineer battalion had more equipment than our entire Army group. Lieutenant Hans Müller testified about combat experience. I saw the Remagen bridge. I saw 50 prepared demolition charges. I watched 4 months of preparation neutralized in 11 minutes by American engineers who cut wires while under fire. The Americans didn't just outproduce us. They revolutionized production itself. They created abundance where we struggled with scarcity. At Nierstein, I watched them build a bridge while we shot at them. They continued working. More engineers appeared. More equipment arrived. We destroyed sections. They replaced them. We could kill men, but we couldn't stop the operation because there was always more equipment, more engineers, more supplies. Additional testimony from captured German engineers documented the psychological impact. We brought Prussian discipline to a contest of industrial abundance. Their excess capacity exceeded our maximum effort. They could lose 40 bridges and replace them in a week. The mathematics were crushing. They produced in one day what required us 1 month. Oberst Martin Schreiber, commander of the 47th Engineer Battalion. At the Rhine, we prepared 17 defensive positions with 6 months of labor. American engineers crossed at all 17 points within 14 days. They had more bridging equipment in forward depots than we had ever manufactured. They had more explosives at battalion level than we had for the entire front. Their engineers were not better trained than ours. They simply had unlimited resources. Production statistics stated by German engineers revealed the disparity. American production of military explosives, 564,000 tons in 1944. German production, 33,600 tons in 1944. Single American explosive plant monthly production, 47,000 tons. Entire German chemical industry monthly production, 2,800 tons. American production of Bailey Bridge components, 148,800 tons in 1944. German production of equivalent bridging, 2,160 tons in 1944. Single American factory monthly production, 12,400 tons. Entire German bridge fabrication monthly production, 180 tons. The numbers documented not just superiority, but orders of magnitude difference in industrial capacity. Testimony revealed German awareness of the disparity. Fischer had compiled intelligence showing American capacity exceeded German capacity by factors between 17, 1 and 69, 1 depending on the specific equipment category. He had briefed this intelligence repeatedly. Command had dismissed it as impossible, as propaganda, as defeatist. The assumption that German technical superiority and tactical skill would overcome material disparity proved false. American engineers demonstrated that adequate training combined with overwhelming material created unstoppable tactical capability. German defensive engineering, executed with courage and skill, failed against systematic application of industrial superiority. Combat engineers stated the mathematical certainty. We could not destroy bridges faster than they could build them. We could not expend explosives faster than they could manufacture them. We could not replace equipment as fast as they discarded damaged equipment. The crossing operations succeeded not because American engineers were better, but because American factories were better. We lost before the first bridge was built because we could not match their production. Every tactical decision we made was correct. Every defensive position we prepared was adequate. The outcome was determined by factory capacity, not tactical skill. The productive capacity differential extended beyond bridging. American production of military trucks, 812,000 vehicles in 1944. German production, 88,000 vehicles in 1944. American engineers had trucks to waste. German engineers rationed fuel for essential operations only. American production of construction equipment, 47,000 units in 1944. German production, 2,100 units. American engineers had bulldozers at company level. German engineers shared equipment at division level. American production of communications equipment exceeded German capacity by similar ratios. American engineers coordinated operations with abundant radios. German engineers relied on telephone lines that American artillery cut. The interrogations documented that German engineers recognized the inevitability once they understood the production differential. Fischer calculated in January 1945 that American crossing operations would succeed regardless of German defensive preparations. His calculations proved accurate. The Rhine crossing succeeded at every attempted point. The defensive engineering that had held for 5 years collapsed in 3 weeks not because Germans stopped fighting, but because Americans brought such overwhelming material superiority that tactical skill became irrelevant. Combat engineers described fighting Americans as fighting an opponent who could afford to waste more resources than Germany could husband. They fired artillery to suppress a single machine gun. We rationed every artillery round. They built bridges knowing we would try to demolish them, then rebuilt them knowing we had limited demolition capacity. They accepted casualties because they could replace losses. We avoided casualties because we could not replace anyone. The asymmetry was total. They fought with abundance. We fought with scarcity. Abundance won. The American combat engineer system proved that democratic industrial capacity, properly mobilized, created military capability that totalitarian discipline could not match. Free workers in American factories outproduced slave labor. Market-driven efficiency exceeded command economy allocation. The flexibility of American industrial organization allowed rapid scaling that German centralized planning could not replicate. The Rhine crossings demonstrated that wars are won in factories as much as on battlefields, and that industrial democracies fighting total war bring productive capacity that authoritarian states cannot match. February 14, 1945. SS-Oberführer Heinrich Brandt had laughed at American engineering capacity, dismissing production statistics as impossible and tactical skill as inadequate. May 8, 1945. His body lay in a collapsed bunker near Dusseldorf, killed by American artillery that expended more ammunition destroying one target than German artillery received monthly. Their mockery became history's most expensive miscalculation. The Rhine River crossings cost Germany 34,000 casualties. American combat engineers crossed at will using industrial capacity that exceeded Axis combined production by factors exceeding 10, 1 in most categories and 69, 1 in bridging equipment specifically. The combat engineer battalions proved that democratic production outperformed authoritarian command. Free workers in Detroit, Amarillo, and Pennsylvania built the bridges that crossed the Rhine. They worked for wages, with union representation, under safety regulations, and they produced more than slave laborers forced at gunpoint. Margaret Kowalski's riveting station exceeded Krupp's output. James Washington's hydraulic press exceeded Skoda's production. Mary Chen's nitration process exceeded I.G. Farben's capacity. They did this working 8-hour shifts with lunch breaks, safety equipment, and the right to quit. American abundance demonstrated that free peoples properly motivated and equipped generate productive capacity that authoritarian systems cannot match. Industrial abundance buried ideological superiority under 148,800 tons of bridge steel, 564,000 tons of explosives, and 812,000 trucks. The Rhine crossings proved that totalitarian military efficiency meant nothing against democratic industrial capacity. German engineers fought skillfully and bravely. American engineers won overwhelmingly and systematically. The difference was not courage, not training, not tactical doctrine. The difference was that American factories produced in one day what German factories produced in 1 month, and that industrial differential determined the war's outcome before the first combat engineer hit the beach at Normandy. The lesson remains: dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity when fully mobilized for war invites catastrophic miscalculation. The Reich believed superior soldiers would overcome superior factories. The Rhine River crossings proved that when free peoples decide to fight, their factories become unstoppable weapons that no amount of tactical skill can defeat. The combat engineers who crossed the Rhine in March 1945 won, not because they were better soldiers than their opponents, but because American factories gave them unlimited capacity to overcome any defense through systematic application of industrial abundance that authoritarian command economies cannot replicate.